Hello, welcome to Notes 7.01. Today we're doing special right triangles. So we know that typically in a right triangle, if we're given two sides, let's say 8 and 10, we could use the Pythagorean theorem to find the third side. Well, in some cases, they only give you one side and some angle measures. And this is kind of the beginning of what trigonometry is when you're given a side measure like 10, an angle measure like maybe 32, as in 32 degrees, and you were asked for one of the other sides of your shape because by default, 180 minus 90 minus the 32, so really 90 minus 32, we would know our other angle to be 58 down here. But we could use what's called trigonometry, sine, cosine, and tangent. So we have an acronym, SOHCAHTOA, TOA. You're going to be learning in our next lesson that will help you find the third side of, any sides of a right triangle given an angle measure and a side measure. All right. But today we have two special cases, the 45, 45, 90 right triangle and the 30, 60, 90 right triangle, which is down at the bottom of the page there. Okay. How the rule works is if you are given 45, 45, 90, making it an isosceles right triangle, it's kind of the end of the last notes there. If this is an isosceles right triangle, then the rule goes like this. Across from the 45-degree angle is one side measure. I'm going to make that generically an x. Across from the other side, 45-degree angle is the other equal side. We're going to call that x as well. If this side is x and this side is x, the hypotenuse is x times the square root of 2. Right? And the reason that works, I'm going to give us a quick example here with number 1. This side is 3 and this side is 3. If we use the Pythagorean theorem to find the third side, we have 3 squared plus 3 squared equals c squared, which gives us 9 added to 9 is c squared. And here, I just want you to notice we're adding two perfect squares together. So we get 18 equals c squared, and then we go take the square root of each side. Well, when we go to branch and reduce that radical, aren't we going to break it into this 9 that we just added twice together? Becomes 3 square roots of 2. So if this side is 3 and this side is 3, then the hypotenuse is going to be 3 square roots of 2. That's our rule. Right? So if you have a given measure x and another given measure x, then the hypotenuse is that measure times the square root of 2. So using that for the next few examples, if letter A gives us that this side is 9, and then by 45 degrees there and 45 degrees here, it does make that isosceles. If this side is 9 and this side is 9, my rule says that the hypotenuse here is that same measure times the square root of 2. So it's going to be 9 square root of 2. Okay. The reverse process, here we're given it's an isosceles triangle. So this is 45 and 45, making each of these sides our measure of x. And we're given the hypotenuse. If the hypotenuse is x square roots of 2, as per the rule I'm giving you today, then the x value ends up being 10. So each of these sides must be 10 and 10. And looking at letter C, again, if that angle measures 45, we have 45 degrees there and 45 degrees here. Tells us two sides are equal because we have two base angles equal. So 3 square roots of 6 matches to here, 3 square roots of 6. And the hypotenuse, just like we have a hypotenuse up top, is that same measure times the square root of 2. So I'm going to take 3 radical 6 times the square root of 2, and we're going to get 3 radical 12, because we know from our last lesson that we multiply the numbers under a radical. Well, that's not simplified, so we're going to have to go in. Square root of 12 becomes square root of 4 times 3. I'm going to drop down this 3 that I had out in front. And 3 times 2 gives us the whole hypotenuse here would become 6 square roots of 3. I'm just going to verify that in my calculator. So again, a squared plus b squared should equal c squared. Okay. So if you don't believe us, or if you got lost in translation here, okay, if we take 3 square roots of 6 squared plus that same thing again, a squared plus b squared is what I'm doing here. 3 square roots of 6 squared. Is that equivalent to the hypotenuse 6 radical 3 squared? So 6 square roots of 3 squared. This coincidentally ends up being the reverse digits where the 3's out front and the 6 is underneath, but it does. So in this case, a squared plus b squared equals that 3 radical 6 times the square root of 2 squared. All right. So that's our 45, 45, 90 right triangle, meaning the two equal sides repeat, and that measure gets multiplied by your square root of 2 as the hypotenuse. 30, 60, 90 rule is a little bit different. How this one works is we have 3 angle measures, 30 degrees, 60 degrees, and 90 degrees. So again, this is the special case when you're given any triangle with 30, 60, and 90. How this works is we have x, x radical 3, and 2x, okay? Kind of as scale factors, right? So if the 30-degree angle is the smallest, across from that is your given value 1. And across from 60 is the square root of 3. Well, if I put 1 squared plus square root of 3 squared, that's always going to equal 1 plus, well, the square root of 3 squared becomes 3 equals c squared. 4 is c squared, makes that hypotenuse 2. So this is the simplest form. What we can do is we can dilate that triangle twice as big, where this angle stays 30, but this side here might become 5. Therefore, this hypotenuse here becomes 10. Well, if this becomes 5 and this becomes 10, I really took this side of 1, multiplied it by 5. I took this side of 2, I multiplied it by 5. And that means this third side, the square root of 3, I'm going to multiply by 5, becomes 5 square roots of 3. So that becomes really a scale factor. So whatever your shortest side is, meaning the one opposite your 30-degree angle, we look to the hypotenuse and we double that. Then we take the longer leg and we multiply it by 5 radical 3. So how that works here is that this hypotenuse is equivalent to twice x. So if twice x is 10, then x must be 5. Meaning the shortest side, 5, is opposite your 30-degree angle down here. And if this side is 5 and this side is 10, then this side is the short side times radical 3. It's just how it works. All right. So across from the 30-degree angle is your measure of x. Across from the 60-degree angle is x times radical 3. And across from the 90-degree angle is twice x. So looking at this triangle here. Now again, we're using our 30, 60, 90 rule. We can't use the Pythagorean theorem. Okay? We don't know the measure of either of these sides to say a squared plus b squared gives me c squared. But we do know that the sides of a 30, 60, 90 right triangle, and I'm drawing it sideways here for us, that across from the 30-degree angle is some measure x. Across from the 60-degree angle, and I say across, meaning not one of the two sides that touch the 60-degree angle, the opposite side to there, is x times the square root of 3. And the hypotenuse is always twice x. So these three measures, x times radical 3, and 2x, are what falls on these three sides. So I'm going to kind of scribble out the y for a second and the x, and just say that from the 30 degrees, we have this side to be x, across from the 90 is 2x, and across from the 60 is x square roots of 3. Now the only measure given is that 22. So if 2x is represented by 22, then our scale factor must have been 11. So 11 is our value of x, meaning the side over here is going to be 11, and this side is going to be 11 square root of 3. So that's just how the rule works. So if I go over in my calculator and I start typing in 11 squared, so again, the only number we were given is that hypotenuse, right? So if I were typing in 11 squared plus 11 radical 3, I forgot my parenthesis, plus 11 square roots of 3 squared, that's going to equal to 22 squared, 484, right? So again, from the 30-degree angle, opposite that is the x value, okay? Across from the 90 is twice x. So y is going to be 2x. So if that x value is 5, then the hypotenuse is 10. And the third side, the third angle in that triangle is going to be 60. So this third side is going to be 5 square roots of 3. Actually ended up being a rotation of that first picture. Okay. On the practice questions, I'm actually going to skip these tables. Okay. Decided I really don't like them, and they kind of complicate the situation for us here. I feel like going down here to an example that makes a little bit more sense, is a little tangible, is helpful. So again, the rule for 30, 60, 90, we're going to write one more time. So here I drew a scalene triangle, right? One side, a longer side, and the hypotenuse. From the smallest angle being 30 degrees, opposite that, over here to my left, is a measure of x. Okay. Across from the 90 degrees is twice whatever that length was, 2x. And then the third angle would be 60. So opposite that ends up being the measure of x, so whatever this side here is, times the square root of 3. So looking at number 6. Triangle rat has angle R is 30, angle A is 90, so I'm going to put my A here, and angle T is 60. Now this angle looks smaller to me, so I'm going to make that the 30-degree angle R and put T down here as 60. So if I'm thinking about that triangle I just drew up top, across from the 30-degree angle is side X. Across from the 60-degree angle is our x square root of 3. And across from the right angle is twice x. Okay. So those are the three sides that we know given these three angles. Okay. Now, what they're telling us is that little r is 12. Little r is what's opposite capital R. So if our big angle here is angle R, these two sides are touching that angle R, it's the opposite side. So in this case, x is going to be 12. So if x is 12, then x times the square root of 3 is going to be 12 square roots of 3. And the third side is twice x. It's going to be 2 times 12 is 24. Not sure why I put parentheses there. Didn't need those. So if this side is 12, AR is going to be 12 square roots of 3, and RT is going to be 24. So again, the only information given to us was one side length. Well, we were able to find all 3 side measures given this rule here. Going down to triangle LMP, L is 30, so I'm going to put L down here because that appears to be the smallest angle. M is the 90, and P is going to be our bigger angle, 60. Well, again, going back to the rule, from the 30-degree angle, opposite that is a measure of x. Across from 60 is x times the square root of 3. And across from the biggest angle is twice x. The only measure given to us is little p is 16. So little p is what's across from our 60-degree angle is 16. So 16 equals the square root of 3. Equals x square roots of 3. Well, we got to somehow find out what x is. Okay. So 16 equals the square root of 3. What we're going to do is solve for x. So we have to divide by the square root of 3 on each side. Oh, no. So in this case, we get 16 over the square root of 3 equals x. But we can't do that. We can't have a radical down in our denominator. That's what our last notes page told us. So we're going to multiply by radical 3 over radical 3. So x will really become 16 radical 3 in the numerator over 3. So the x value, meaning this side here, p to m, is going to be 16 radical 3 over 3. And our hypotenuse is going to be twice that measure. So this is where the radicals really kind of get a little funky, is twice the x value. So twice our x value says twice 16 radical 3 over 3 becomes, well, 16 times 2 is 32 square roots of 3 over 3. Lots of radicals happening there, but that's kind of how our last notes and our new notes kind of tie in together. Right? The next page has a little bit of everything as your homework today, your classwork. So looking at exercise 1, simplify these radicals. Remember, when you're adding and subtracting, you need like radicals. So a little hint here would be to reduce the square root of 898 first. 49 goes in 2 times. So you'll have 4 square roots of 2 is beginning here, plus square root of 98 becomes 7 square roots of 2 is going to give you a final answer of choice B. Now, if the radicals are kind of getting you a little confuzzled, you can always go back to your calculator and use this to kind of help yourself through some of these. So 4 square roots of 2 added to the square root of 98. This is like a double check. We get 15.556. And if you go through and check each choice, all right, only one of them should equal that same answer. So 11 times the square root of 2 ends up being the same answer. Okay, so I did it by reducing radicals, or you can try to type all those radicals into the calculator. So try your best here. Again, 1 and 2 are like 7.00 notes. Okay, and that's from last week or a couple weeks ago. Exercise 3, you're trying to decide what symbol goes between this side and this side. Is it equal? Is it congruent is what this one says. Oh, actually, my bad. This symbol should be not equal to. Is this side greater than that side, or is this side less than the other? So we're really looking for what symbol goes between them. Exercise 4 is some multiplication. So that's your note 7.01 from here that we did at the beginning. I should say 7.01a. It's multiplying radicals. Same thing with 5 and 6 is multiplying and dividing them. 7 and 8, that was from note 7.00 if you need help. Number 9 is your special rate triangles, 30, 60, 90. Okay, so again, across from 30 is side x. Across from the 60-degree angle is x square roots of 3. Across from 90 is a measure of twice that x value. 10, you can look back to our notes. 11, 12, and 13 is all special rate triangles. So the new stuff we just did on 7.01 is 9 through 12. Good luck. We appreciate all your hard work. Thank you.